Okay, if you've ever been anywhere near a hearing aid, you know that sound. That sudden, high-pitched whistle that just seems to slice right through a room. Well, today, we are going to solve the squeal. We're pulling back the curtain on that super annoying thing called acoustic feedback and diving into the incredibly smart technology that the world's best hearing aid makers have designed to make it just disappear.
Right? It's a sound everyone recognizes. And, let's be honest, everyone finds annoying. But this squeal, or feedback, it isn't just some minor glitch. Nope, it's actually one of the oldest and most stubborn challenges in hearing aid tech. It can be kind of embarrassing for the person wearing it and frustrating for everybody else. But you know what? The real problem goes way, way deeper than that.
So what is actually going on here? Well, in the simplest terms, acoustic feedback is a classic closed-loop system that's just gone rogue. You know when a microphone gets too close to a speaker at a concert and you get that awful screech? It's basically that. The hearing aid is hearing its own amplified sound, and then it amplifies that sound all over again, creating this vicious cycle that spirals out of control into that whistle we all know.
Let's break that loop down. It's really just 4 simple steps. First, sound goes into the hearing aid's microphone. Easy enough. Second, the little computer inside amplifies that signal so you can hear better. Third, some of that now louder sound is going to leak out of the ear canal. It's just inevitable. And fourth, this is the kicker, that escaped sound gets picked right back up by the microphone, and boom, it's sent right back to the start of the loop to get amplified even more. And on it goes.
And listen, this isn't just about a pesky noise. The consequences are a really big deal. From a clinical perspective, feedback puts a hard limit on how much amplification a person can get, which could mean they miss out on hearing crucial sounds in speech. And even before you hear a full-on whistle, there's this thing called sub-oscillatory feedback that can make everything sound harsh and tinny. It just wrecks the sound quality and makes it harder to follow conversations. It is a major roadblock to getting good hearing care.
So, how in the world do we fix it? Well, the evolution of the solution has been this amazing journey, really, from what was basically brute force to some incredible digital finesse. The early methods, they were purely subtractive. The only way to stop the whistle was to take something away. You could turn down the volume, which, completely defeats the point of a hearing aid, or you could use something called a notch filter that just chopped out the entire frequency where the feedback was happening. The modern way is totally different. It's additive. Instead of just removing sound, it actually creates a new signal to actively cancel the feedback out.
The hero of this story is a technology called adaptive feedback cancellation, or AFC for short. You can think of it as a mimic and subtract engine. The system creates this perfect digital copy of the sound that's leaking out of your ear. Then it generates an identical signal that is perfectly out of phase. It's like creating anti-sound. So when the real feedback meets this anti-sound, they just cancel each other out. Gone.
And the impact of this? It is absolutely huge. This number you see here represents the added stable gain. That's the extra 15 to 25 decibels of amplification headroom that users get without any feedback. This is a game changer. It gives audiologists so much more power to fit more severe hearing losses and deliver the clarity people really need.
But, like any good superhero, this powerful system has its kryptonite. There's a complication that engineers have been working like crazy to solve.
So here's the big catch. The system is designed to hunt down and destroy stable tonal sounds that it thinks are feedback. But what happens if that sound isn't feedback? What if it's a pure note from a flute, or a smoke alarm, or a beautiful piece of music?
Well, there's a name for this, and it's called entrainment. It's what happens when the feedback canceller gets a little too smart for its own good and mistakes a sound you want to hear for feedback. When it tries to cancel that music, it creates all these weird sounds, distortion, and a warbling quality. So the really crucial part isn't just canceling feedback, it's correctly identifying it in the first place. To solve this puzzle, manufacturers now use a kind of hybrid toolkit. So that phase inversion, our anti-sound engine, still does all the heavy lifting. But they also add a stabilizer, a teeny, tiny, totally imperceptible frequency shift. By slightly changing the frequency, it helps the system tell its own signal apart from an external one, which helps break the loop. And finally, there's a safety net. Adaptive gain control, which can, as a last resort, just dip the volume in a super specific frequency band for a split second.
Okay, now here's where it gets really fascinating. While all the big manufacturers use this basic toolkit, they each apply it in their own unique way, and it's all driven by a core design philosophy.
Let's start with Audicon.
Their philosophy is all about creating an open soundscape, giving you access to the full 360 degrees of sound around you. To do that, you need a system that is incredibly fast. Their solution is this unique dual microphone setup where two totally separate feedback cancelers run at the same time. This lets them zap feedback instantly, even while the hearing aid's microphones are changing direction over 100 times per second. For Audicon, speed is everything.
Signia takes a totally different and frankly brilliant approach. They focus on re-engineering the problem itself. See, they realized a lot of people don't like the sound of their own voice, which leads to using very open, leaky fittings. So Signia's own voice processing, or OVP, digitally makes the user's voice sound more natural. This means they can wear a more closed, snug fit, which dramatically cuts down on sound leakage. They basically prevent feedback from ever becoming a big problem in the first place.
For Widex, the #1 priority is preserving their famous natural sound. Their system is designed to be as gentle as possible. It's an intelligent, rule-based controller that looks at how the device is fitted and how close it is to feeding back. It only applies fixes like frequency shifting when it's absolutely necessary, all to maintain that pristine, artifact-free audio they're known for.
Starkey, on the other hand, is all about maximizing raw power. Their philosophy is to engineer a system that delivers the most added stable gain possible. They use a really robust setup process in the clinic to build a super precise model of the feedback path. This lets them crank up the amplification, giving audiologists all the power they need to fit even the most challenging hearing losses.
And then there's Phonak. Their philosophy is all about intelligent identification. Their system, called Whistleblock, uses this really sophisticated tagging module. Its whole job is to be an expert at telling the difference between true feedback and other sounds in your world, like music or alarms. The goal here is to completely get rid of that entrainment problem and make sure the sounds you do want to hear are perfect.
So, there you have it. 5 different manufacturers, all starting with the same core technology, but each taking a completely unique path to get to silence. Whether it's a focus on speed, prevention, sound quality, pure power, or smarts, each philosophy gives them a different strategic edge in the battle against the squeal.
It's obvious these systems are incredibly advanced, right? But for the most part, they're still reactive. They're playing defense. So, what's next?
Just imagine this for a second. What if, instead of just reacting to feedback after it starts, your hearing aid could actually anticipate the situations that are likely to cause it and stop it before it even begins? That's the huge leap from reactive to predictive control. By using AI and machine learning, a hearing aid could actually learn your habits. It could recognize the specific way the acoustics change when you lift a phone to your ear, or put on a hat, or get in your car, and it could preemptively adjust its feedback cancellation model for that exact situation, on the fly.
This is where the technology is heading. The ultimate goal is to make feedback so well managed that it's not just something you don't hear, but something you don't even have to think about, ever. From a simple, annoying whistle to a device that intelligently predicts your acoustic future, it's a quiet revolution in sound.